Hi, welcome to my channel, our chemistry class. So I expect to discuss the IAL chemistry past papers in this channel. So to begin with this paper, so this is the section B of the October 2023 Unit 1. Section B is the one in this video we do discuss, and the section A has been discussed in our previous video. I hope you had a chance to go through that video to see how to approach MCQ questions. So the question number 18 to begin with, the first question in this paper, section B. First part is the section about the elements in period 2 of the periodic table is given. The first ionization energy of some elements in period 2 are provided to you. So in this video, you are provided the basic understanding of how to approach to a structural assay questions to answer. So it is explain the general trend in first ionization energy across the period. 2, it is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and the neon. So the values are provided: lithium 520 and the beryllium is higher than this 900, as comes to the boron 801. Little bit of exceptional value, you can see the value is decreased. Then how it is being possible, and the carbon comes 1086. As well as that reaches to nitrogen, it comes 1402. Oxygen, it gives you the value as a blank that you are supposed to get it, an idea. And the fluorine is next highest, 1681, and the neon is the highest value, 2081. So you can see the neon is 2081. Generally, first ionization energy increase. If you go through your general pattern of variation of the first ionization energy across a period, this is the general trend it comes. It is the first element, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Highest value is the neon. This is your general trend, what you know about. So they're asking generally, there would be some kind of discrepancies, even though generally ionization energy increase across this period also. Using this knowledge, you are asking the general trend in the first ionization energy across the period too. It look at the marks. It gives you 2 marks. Clear indication. They expect 2 points to give this. Why the first ionization energy increase? Obviously, it is the number one reason is as go across the period, nuclear charge increase. Nuclear charge increase because number of protons increase as go across the period. Lithium 3, beryllium 4, 5, 6, 7, 8, 9, 10. Greater the nuclear charge, it is exactly, there would be the electron is removed from the same shell. So it's the same shell for lithium, same shell for beryllium, carbon, nitrogen, oxygen, fluorine, and the neon. Due to the greater the nuclear charge, so it is electron is added into the same shell. Also, shielding is the same because it's the same shell, electron is added. So you are expected to write 2 points. Number 1, nuclear charge increase as so across the period. Because of that, it is this increased attraction of the outer electron by the nucleus. Also, it is the second part is electron is added to the same shell. So the shielding is the same as go across the period. Because of that, it is that ionization energy generally increase. If there is no such discontinuation, it should generally increase like this way. Second part, predict a value for first ionization energy. The oxygen is not given. You are supposed to give a value of oxygen. So what you know about our pattern, it should be slightly less than carbon, and it is the nitrogen is here. Compared to the nitrogen, it is the boron carbon nitrogen increase. It is slightly less than nitrogen. Nitrogen value is 1402. So you can write any value less than 1350. You can write down. Maybe 1340, 1340 to 1350, like any value can be mentioned. It is kind of your prediction. B part of this question where we are referring to the same 18 question, the B part, it continuation of the question. The B part is asking, it is the second ionization energy. Second ionization energy of lithium is given. So you had seen earlier lithium first ionization energy and the second ionization energy. First ionization energy was given to you. This is the first ionization energy that was given for lithium in this table earlier. It was somewhere 520 kilojoule per mole, but you can see there is a huge difference compared to the first ionization energy, 7,298. 7,298 kilojoule per mole. You're asking first part of the B first part, write down an equation to show the second ionization energy of lithium. So it is the second base already positively charged gaseous lithium convert into dipositive gaseous ion by losing 1 electron. If you had written this correct equation, it is 2 marks because formula correct 1 mark and the balancing correct 1 mark including the state symbols. So your second part is why there is a large difference between first and the second ionization energy. Look at the marks again, 2 marks. Second part gives you 2 marks to explain why there is a large difference. To give this to answer to this with these 2 marks to be taken, first thing is you can easily see second ionization energies from already positively charged lithium ion. So to get this, the electron is more strongly attracted by the nucleus, same number of protons. Only 1 electron is lost already. So it is your first point should be, or second answer, second ionization is from already positively charged ion with the greater effective nuclear charge. Greater effective nuclear charge because it is now it is already positively charged, so the remaining electrons are strongly attracted. If you can mention that, it's 1 mark. Second mark should be, it is the second electron you can see for lithium 3, 1s2, 2s1. So the first ionization energy, this 2s1 has been removed. So it is the second ionization energy should be from an inner shell, which is closer to the nucleus. Obviously, ionization energy is higher. Second 1 mark is the second ionization take place from an inner shell which is closer to the nucleus is 1 mark. Second mark is that it is having greater effective nuclear charge because it is 1 electron already lost. It's a positively charged ion. Same question, there is a C part 18 question. It is referring to the beryllium chloride that is being asking about this C part of this question number 18. In the gaseous phase, beryllium chloride exists both as a simple molecule of BeCl2 or else it exists as a dimer, which is we call 2 beryllium chloride join up in order to produce it is 2 beryllium and 4 chlorine. We call it is a dimer. In the captive state, it exists as either PeCl2 or PeCl2 dimers. You are asking to draw the dot and cross diagram. See first one with beryllium chloride. Beryllium has 2 outer electrons, so it shares with 2 fluorine atoms. So each fluorine has 7 electrons in its outer shell. So in this context, it is having each fluorine completed outer shell, but beryllium is not. So the dot and cross diagram, you can see it is beryllium fluoride dot and cross diagram for 1 mark. Second one, the shape in the bond angle. Look at the marks, it's 4 marks. Shape is linear because it is the bond angle is 180. So if you identify the shape 1 mark, bond angle 1 mark, explanation is the 2 marks. So the 2 marks are given for both bonds in beryllium fluoride. Here 2 bonds because 1 beryllium is attached to 2 chlorine. 2 covalent bonds are present in these 2 covalent bonds. They have been separated with maximum separation with minimum repulsion. Because of that, it gained a shape of linear. So in the same question, see, third one, it is asking based on, it is the draw a diagram to show how the beryllium fluoride bond together to form a dimer. Stating the type of bond involved. So it is in the dimer, it is 2 BeCl, 2 molecules linked together. So in this context, it produces a dimer. You are familiar with aluminium chloride. How does it produce? Same way, beryllium chloride dimer. And there would be another beryllium chloride. So it should be dative covalent bonds by electron pair of 1 chlorine and the electron pair of another chlorine here. You can see this dimer is produced through 2 dative covalent bonds. So it is the dative covalent bonds are there. So it is exactly the blue color bonds are dative covalent bonds. So you are given these 2 marks for this D part. End of the question number 18 is 16 marks. We are moving on to the question number 19, which is the second question in the section B. So it is the question number 19. It's based on, it is the fuels. So there's many car use fuels contain ethanol as well as hydrocarbons. So the E numbers of these fuels show the percentage by volume of ethanol in the fuel. So there are 2 types of fuels. They describe E5 fuel as well as E10 fuel. So you can identify immediately E5 and the E10, the difference. In the E5 fuel, it is the ethanol 5%. C2H5OH percentage in the E5 fuel, I'm writing it separately. So you can get an idea. Ethanol is 5% in the E5 fuel, but the ethanol present in 7.8% in this E10 fuel. So the 5% is ethanol. So obviously 95% would be the hydrocarbons in the E5 fuel. So this is the E10 fuel 92.4. So it is 95% is reduced to 92.2 in the E10 fuel. Also, it is provided energy density of hydrocarbon as well as energy density of this the ethanol. Ethanol energy density is provided to you as the value which is given to you 46.5. 46.5 megajoule per kilogram released by ethanol. Also, energy density of ethanol is 46.5 and this is 46.5 is the hydrocarbon This is the energy density of ethanol is 29.7. 46.5 megajoule per 1 kilogram. It is the large quantity by hydrocarbons. So once you arrange the given information, it is much easier. Your first part of the question 19, A part, the first one. Having all this information written clearly, calculate the mean energy density of this E10 fuel. E10 fuel mean energy density. So E10 now you can see 7.8 of ethanol which released 29.7 megajoule per kilogram. So your answer will be, it is the 92.2 out of 100 multiplied by, it is 92.2. They are asking for E10 fuel 46.5. That's the mean energy or the average energy by E10 fuel. 92.2 would be hydrocarbons which release 46.5 plus it is 5 out of 100 release. It is the energy would be 29.7. Once you get the average value for this answer, so when you add it up, you can separately simplify and add the two values, it becomes 42.87, 42.873 to be added into 2.3168. So you get the answer, mean energy value 45.2 megajoules per 1 kilogram. It comes for a first one as the mean energy with 2 marks. And the second part of the question, it says, the second part, energy density of a E10 fuel. So the average energy, mean energy 45.2 megajoules per kilogram. We did the first part. The second part of the question, it asks, find the energy density mass of the Find the mass of 1500 centimeter cube of this E10 fuel. So E10 fuel is the second part of the question. It has the density 0.729. Density is 0.729 gram per centimeter cube. Your question is find the mass. So always density is equals to mass divided by volume. Your question is to find the mass in grams. So the cross multiplication, density into volume, it gives 0.729 gram per centimeter cube multiplied by 1500 centimeter cube. So you get the answer by simplification for this one. It would be 1093.5. So the mass comes 1093.5 grams. 1500 centimeter cube of E10 fuel. Once you simplify this, you get the answer 1093.5 kilograms. So you are asking to calculate the next part, which is your third part. The second part of the question, mass of the E10 fuel 1093.5 grams is present. So your immediate next question, the third part. Once you calculate the mass, third part is asking to find energy. Calculate the energy released when this 1500 centimeter cube of E10 fuel burn in excess oxygen, and you are asking to use the information, and the answer is E10 fuel. You are supposed to use the given value of 38.1 if you did not get your answer, but it is 45.2. We got the answer earlier. Mean energy. Mean energy value we had calculated earlier as 45.2 megajoules per 1 kilogram. So to find this energy release, you have to convert this mass, which is 1093.5 grams, into kilogram. You can divide that by 1000. So the mass will be 1.6 0.0935 in kilogram. This much of kilogram when burned, you are asking for 1 kilogram releases 45.2 megajoule. This answer can be taken this much of megajoule released by 1 kilogram. Therefore, 1.0935 kilogram should release 45.2 times 1.0935 and this much of megajoule per this value. So what is your simplified value will be 49. It is 415 megajoule released by this much of mass of this 1.0935 kilogram. I hope you understood how to ratio this answer. And in the next part of the question, the B part, many countries are gradually replacing E5 fuels to E10 fuels. So it is that you can see that E10 fuel has more ethanol, less hydrocarbons. So obviously it is trying to reach to more and more with less hydrocarbon fuel. The idea is to limit these issues which had come onto the environment. Explain how this change might result to be more sustainable fuel. Sustainable meaning comes how we can preserve the natural resources, especially finite natural resources. So the B part of the question mainly targeting with 3 marks. It is how can this change might result in more sustainable fuel. Number 1, 4 out of 3 marks here. It expects 3 points. First point here you can talk about, it is the ethanol increase. It is taken mainly from renewable resources. Ethanol is obtained from renewable resources. So renewable resources is more means it is the less finite resources. Finite resources in the sense it is less fossil fuels. So more plant-based renewable resources, it is the ethanol obtained through fermentation. Ethanol is obtained through fermentation. So the fermentation needs less energy. It's a low energy process. Here again, low energy process that also preserve some of the fossil fuels because they one thing use more ethanol, it comes from renewable resources. Basically 1 mark. Ethanol is undergoing fermentation process of glucose. That's how the ethanol is manufactured, which is that low cost process. Also, this entire process releases less carbon dioxide emissions. When you are referring to less carbon dioxide emissions into the atmosphere, so it is less CO2 emissions, so it is obviously, it is the less climate change. So this is related to less climate change because it is less global warming. So you can talk about this ethanol comes from renewable resources, 1 mark. Ethanol comes from the low energy process through fermentation. Also, less carbon dioxide emissions into the environment, 1 mark. So that's how you can gain all these 3 marks, which is given for B part. We move on to the C part of the question, which is based on this fuel and the hydrocarbons. C part of the question. This is given to you again, the introduction of this. Straight chain alkane hexane can be reformed to give a range of products. It was suggested that one such reason that many produce cyclohydrocarbon and hydrogen gas as the only products. Cyclohydrocarbon contains a ring of 5 carbon atoms. So your question is, write the equation for this reaction using molecular formulae. First one is how you can obtain. It is starting from the straight chain alkane hexane. So it is the very first part. It is the safest one. We can see C6H14 converting to C6H12 is the cyclic hydrocarbon. So the hydrogen gas has to be released. This is how using molecular formulae it is to be represented with 1 mark. So it is second part of the question. Second part of the question, it says, draw the structure of the cyclic hydrocarbon form in this reaction. So the second part is that cyclic one. It should be 5-membered ring. So it should be obviously one CH3 group has to have a branching. That gives you 1 mark. And the D part of the question, hexane will react with chlorine in the presence of UV light to form the number of products. The first one in the same question number 19, the first one, it is asking, describe the role of UV light in the initiation step of the reaction. Always look at the marks. The first one has 2 marks. They expect 2 points. First point is that chlorine bond undergo homolytic fission. So homolytic bond breaking by using the UV light. So the UV light provides energy to undergo this, the homolytic bond fission of chlorine bond. Second mark is this generate chlorine free radicals. We need the chlorine free radicals in order to continue the process. It is the UV light provides energy to form chlorine free radicals. At the same time, to break the bond homolytically to form, it is this 2 chlorine free radicals. These are the 2 marks. Second part of this question, the second one, alkane dodecane, which has 12 carbon atoms. And you know it's the general formula should be C12H26. So it is the D second one. So it is C12H26 is the dodecane form in this reaction. We know that it is being started with hexane C6H14. So it is your question is write equations for the propagation step. We already spoke about this initiation of formation of free radicals. It is the propagation step. C6H14. This is the alkane hexane. It should have reacted with chlorine free radical. Chlorine free radicals are much reactive, so it grabs 1 hydrogen from this compound. C6H13 become a free radical. At the same time, it generates hydrogen chloride molecule. Free radicals are so reactive. So in another way, so you are asking the 2 propagation steps. So C6H13 is the free radical. This attack with another chlorine molecule because chlorine is present in the medium. A lot of molecules are there, so obviously generate another chlorine free radical. So this generates a chlorine free radical. At the same time, it is producing C6H13 with the chlorine atom into its structure instead of 1 hydrogen. So it is the 2 propagation steps that are expected for you to write. You can write these 2. And in the termination step, how it is generated, C12H26. So these are propagation. So it is the propagation step always can be identified. It is always 1 free radical used up, generate another free radical. Use 1 free radical, generate another free radical. In the termination step, always there are 2 free radicals are used up. In this context, it should be C6H13 free radical could have been joined with C6H13 another free radical. Product would be C12H26. So you are supposed to write down the formation of C12H26 as a hydrocarbon during this reaction. We came to the end of question number 19. Move on to the question number 20. In the question number 20, that is again based on organic chemistry. It is started by giving with certain molecular formula, the alkenes. So we finished the entire question number 19. So it is the question number 20. First part is alkenes. 20th question is based on alkenes. Straight chain alkene X has the structure. So it is, you can say, 5, it is altogether C5H10, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the double bond is present here. So this is the alkene X, which is C5H10. Having written all this, the molecular formula, it's easier to begin a question. So your A part is, given this structure, straight chain alkane structure. So first one, draw the skeletal formulae of 4 structural isomers of X that are alkenes. So you're asking to write down 4. So it should be 1, 2, 3, 4. You have provided space. It should be with C5H10. So you can get an idea what is the given one is 1, 2, 3, 4, 5. So it should be 10 to A. So you can't get the same name. So you can think about it is the same structure with 1, 2, 3, 4, 5 with the double bond at the beginning. Once you write the double bond at the beginning, it becomes N1N. It is different from the given structure. Also, you can get a structure based on one branching. 4 carbon at the stretch, 1, 2, 3, 4, with one branching here. Now, when you are getting the one branching, it is saying 1, 2, 3, 4, your name. So the name becomes 3-methyl. You are not supposed to write the name, but once you write down the names, you can identify it is not the same compound. It is 3-methyl but-1-ene. 2 isomers are drawn all together. So you can put the same thing with the double bond, where you can see it is the same 4 carbon, where the double bond somewhere, second and the third. So it is the same 3-methyl, but it is but-2-ene. So we got 3 structures all together. So we can have it is with the 2 branching. How can that we get the 2 branching? 1, 2, 3, 4. You can get now 5 with. This is 2 branching with the double bond. 1, 2, 3, 4. It is 2-methyl but-2-ene. We got all together 1, 2, 3, 4, 3-methyl but-2-ene. Now it is the 1, 2, 3, 4, 5, 2-methyl but-1-ene. 2-methyl but-1-ene on the second carbon. 2-methyl but-1-ene. So 2-methyl but-1-ene, we had not written earlier. So this could be 2-methyl but-1-ene. These are the 2 isomers we can go easily with the alkene structures. Then we are asking your second part, why alkene X can exist as geometric isomers with 2 marks. Why it can exist as geometric isomers. This is your second part. Why does it exist geometric isomers? It can give you 2 reasons. Number 1, it contains carbon-carbon double bond, that is 1 mark, which prevent or which restricts free rotation. Carbon-carbon double bond restricts free rotation, which gives you 1 mark. Second mark, you can see around the double bond, there are 2 different groups are attached to. Hydrogen and the methyl group. hydrogen and the ethyl group. Two different groups are attached to on each carbon of the double bond. That is the second mark for this particular coin. B part of the question, another compound Y has a structure. We already spoken about the X structure, Y structure. So this is this B part of the question. Y alkene, it is having chlorine and the chlorine. This is how it's given to you, and then there would be two alkyl groups. You're asking to give the IUPAC name for the compound Y. So to get the compound Y, you can start numbering. Maximum 4, so it is 2,3-dichlorobutane. 2,3-dichlorobutane. This is the name, but the methyl, the chloro group and the methyl groups are opposite carbons are attached to. So you can write down either trans 2,3-dichlorobutane or E2,3-dichlorobutane. Either of them to show it is an E isomer or trans isomer. Second part, the student stated that we are in this B first one is already done. B is second one. B second one, compound Y has polar bonds. That is one student has stated. Compound Y has polar bonds. Yes, it has polar bonds, true, because this chlorine is more electronegative than this carbon. So obviously it leads into polar bonds. Delta negative and the positive charge separation occurs in the molecule. Y has polar bond, yes, so it's a polar molecule. That's the student statement. You're asking to comment on that with 3 marks. So you can talk about is the carbon chlorine bonds are polar. Yes, the student is correct. It contains polar bonds. So for that electronegativity as well as making a statement is polar. So you can get 2 marks. But it is a polar molecule. The student is not correct. It is not a polar molecule. To recognize not a polar molecule, you are getting another 1 mark. And to give a reason why it's not polar, because it is a symmetric molecule, all dipoles are cancelled off. Symmetric molecule. That's the explanation why it is not a polar molecule. All dipoles are cancelled off. So that 3rd mark also taken for this part with out of 3 marks. And the C part of the question number 20, we are moving on to same question number 20, the C part. C part of the question, they talk about that bisabelines are group of compounds found in plants and fungi. Bisabeline molecule contains several carbon-carbon double bonds. So it is that bisabelines, these are group of compounds. These introductions are provided. Where do they present? So there is one type of alpha bisabelane. So it is 5.5, 1 gram of that is being reacted with hydrogen gas, 1873 centimeter cube of hydrogen gas. Reaction happened at 150 and the pressure, you are given this temperature and the pressure, and it is given to you temperature 150, so it has to be attached to 273 to make the temperature in Kelvin, 423 Kelvin. Pressure is straight away given 1.52 times 10 to the power 5 pascals. So your question is, it is to identify number of moles of bisabelines in 5.51 gram. That is the first part of the question. So 5.51, and you are supposed to use this molar mass 204. Molar mass is given 204 for this particular bisabeline. So you can calculate the number of moles present in this 5.51 gram. Get the key values and make very sure that you have all these values. 204 of bisabilene. If you get this much of gram, it is 1 mole of the compound. If you get 1 gram, it is 1 divided by 204. If it is get this much of moles are in 1 gram, but now you have 5.51 gram. So you have right now 1 over 204 multiplied by 5.51, where you get the answer. This is 204, and you get the number of mole 0.02701. 0.02701 moles are present in this bisabilene, not 2701 mole. If you get the answer, this is 1 mark. Next is to calculate number of moles of hydrogen gas which is reacted. For that, you should use this ideal gas equation, which is based on this information. You can use PV is equals to nRT and the N is equals to PV divided by RT. So with this information provided, you can take your number of mole onto one side. So this number of mole equals to pressure into volume divided by R into T. Pressure we had already calculated in a standard form, 1.52 times 10 to the power 5. Volume is given in hydrogen, 1873, but in centimeter cube. But you have to convert that by multiplying 10 to the power minus 6 to convert in meter cube. 1.873 times 10 to the power minus 3 in meter cube. So you can substitute always this has to be in meter cube in ideal gas equation. So this into 10 to the power minus 3 divided by 8.31. Temperature we calculated 423 in Kelvin. Once you do write down like that, you can simplify to get the answers. 0.081 mole of hydrogen gas. Number of moles of hydrogen used is 0.081. Next one, you are asking to use the third part, number of moles of carbon-carbon double bonds, which are present in alpha-bisabilene. So after getting both this number of moles, it's very clear. You can get the idea of this ratio of this two compounds reacted. So the alpha-bisabilene to hydrogen, the ratio is 0.02701 mole react with 0.081 mole. Therefore, 1 mole to get, you divide both with this, the smallest number. So this become 1 and this divide by 0.2701, answer become 3. So you can see is exactly there are 3 carbon-carbon double bonds are present in this particular compound bisabilene. We move on to the D part of the question, the repeat unit. So it is the C part of the question is done. In the D part of the question, it gives you part of this polymer structure is given to you. It is having this carbon-carbon double bond here, and it is gives you idea of this repeating unit. So in this repeat unit of this particular polymer, it is given to you continuation here, at the same time continuation. So once it's given to you this continuation like that, it's understood skeletal formula of the monomer. What you should do is you have to get rid of this one, get rid of this one at the double bond. That's the easiest way you can approach into a polymer. So you are getting this monomer and it gives you 1 mark. And the second part, this is the 20th D part, which is the first one. Second part, sample of polyisoprene has a relative molecular mass. So it is that MR value is given to you 50,250. Calculate the number of repeat units. To get this one, you should find the MR of this monomer. Once you calculate 1, 2, 3, 4, 5, it should be having 5 carbon and 8 hydrogen. See, 5H8. So the molar mass is 12 times 5 plus 8. So it should be 68. So if you get 68, it should be 1 repeat unit. You divide that by 68. So you get the answer 739 as well as it is this as the whole number. Nearest whole number, you can obtain that number of repeat units. It should be closer to 739. E part of the same question number 28 is based on incinerators. Incinerators, use in order to get rid of this that polythene waste, basically polymers. They use that polymer waste have the system to remove waste gases. So the E part of the question with 2 marks suggests why this system contains solid calcium hydroxide. Why they contain solid calcium hydroxide, and again this is why solid this calcium hydroxide, and the second part why it is finely powdered. So when you answer to this question, you should answer to each of this point. Why solid calcium hydroxide 1 mark, why finely powdered 1 mark. That's how you get this for the marks. So to answer the first part, why solid calcium hydroxide? Because calcium hydroxide is basic. There are lots of acidic gases are coming out from the polymer burning through the incinerator. So it is absorbing acidic gases such as hydrogen fluoride, sulfur dioxide, as well as carbon dioxide. That is why calcium hydroxide is used. Recognize this one mark. Why finely powdered? Because it is that more surface area. So it is the rate of the reaction is higher. Rate is higher when it is finely powdered. Mentioning that can be taken the second 1 mark. So we came to the end of question number 20. We move on to the question number 21. Question number 21, which is the last question of this paper in this section B of this May June 2023 paper. It is based on minerals contain metallic elements. Question number 21. They had given the introduction about a substance, a green mineral. It is that ceratite contain. It is the A part. Introduction is given. Basic nickel 2 carbonate. Nickel 2 carbonate formula is given in this structure. It is Ni3 as well as it is with CO3 and OH3. Also, it is hydrated with 4H2O. So this question number 21, A part. First one, you are given this. Nickel 2 carbonate can be formed by the reaction of nickel 2 sulfate with sodium carbonate under alkaline conditions. The equation is given to you. You are asked to find the relative formula mass of basic nickel 2 carbonate. So your structure is given here. When you are attacking this, how many atoms? 3 nickel plus 1 carbon and 3 oxygen plus again 3 oxygen plus 3 hydrogen plus 4 times 18. It says here water has a mass of 18, 4 times 18. Can substitute as the nickel has a value 58.7 times 3 plus 12 plus 3 times 16. Again 3 times 16 plus 3 plus 4 times 18. 4 times 18, you can add this the molar value here. 4 times 18. When you substitute all and then add it together, it has to be 376.1. That's the molar mass of this entire compound, nickel carbonate hydrated compound. So it is the first part of A, which gives you just 1 mark to find this molar mass of this compound. Second part of the question A, second one, it's asking about to find the percentage atom economy. Percentage atom economy for the formation of this basic nickel 2 carbonate by the reaction. So you can see when the nickel 2 carbonate is produced, it generates 3 sodium sulfate. Na2SO4 3 times are also generated. So you can see in this calculation, so it is that MR of this desired product. Molar mass of desired product can be divided by total mass of products. Total mass of products. You can go with the reactants as well, but this is the convenient method into 100. Once you use this formula, desired product mass is 376.1 and 376.1 plus 3 times sodium sulfate. Sodium sulfate has molar mass 142.1. When you multiply that into 100, you can obtain more the percentage atom economy 46.87. So it is can be to the nearest whole number is 46.9%, or else you can leave 47% to the nearest whole number also, because it is not mentioning asking for significant figures or a number of decimal places. So you can choose one of the answer. You can leave it with one decimal or else to the nearest whole number. Both are equally correct. Give a reason the use of relative formula mass is not appropriate in this first one. Obviously, it is not appropriate because nickel 2 carbonate is a giant lattice structure. It is consists of ionic bonds, ionic attractions, opposite charge ions. So there are no molecules present in the nickel 2 carbonate. We move on to the B part of this question. So after talking about this, the percentage atom economy is the same question, the B part. B part, it says, chemists often simplify full chemical equations to ionic equations. Electronic configuration of nickel ion present in the nickel 2 compound. So you're asking the nickel 2, before writing nickel 2, it's advisable to write down nickel. Nickel is 28 in this periodic table, the atomic number. So you can begin with, it is the 1s2, 2s2, 2p6, and 3s2, 3p6, 3d vacant, 4s2 filled, and the 3d8. So the nickel 2 plus, most of the electrons are lost. Therefore, 2s2, 2p6, 3s2, 3p6, and 3d8. And you're asking to write down the ionic equation to form this basic compound. So it is your second part of the equation. To generate this entire structure with the nickel tray as well as carbonate tray with the OH tray and the OH2O, you need in this one, it is obviously 3 nickel 2 plus is needed. Also you need carbonate ions. So it is that carbonate ions are needed. With this, the OH wants to come for OH minus. So it is needed carbonate ions, CO3, and it is that CO3 2 negative, 4H minus, and the 4H2O. All these are the ones ions are remaining after concealing of sodium and the sulfate ions, which are the strictate ions. Last part of this is the C part of the question with the calculation about the same question is continued, and it is the last part of the question number 21, C part. In the C part, it is a different question, not it is related to this nickel compound. So it is a different compound would be given to you. You are given the equation in the C part. So it is the 2xSO4. You are given the balanced equation 2xSO4 reacted with 2 sodium carbonate. This is reacting with water molecule also. It generates S3 reacts X2CO3 as well as it is a OH 2 times plus 2 sodium sulfate Na2SO4. So these are the products Na2SO4, 2 of them. At the same time, it generates carbon dioxide. This equation is provided to you with your reactants as well as the products is given to you. This would be your products. So these are the reactants changes into products. Your question is 1.995 grams. This is the given information. Mass is given 1.995 grams of XSO4 is reacted with excess. We are not bothered about the excess sodium carbonate, but it generates 150 centimeter cube of carbon dioxide. These are the important things, so you should circle and keep your best attention of these values. Excess sodium carbonate, it is not an important issue. The room temperature and pressure, it is being measured. Molar volume is given. Your question is to find the relative formula mass of this compound XSO4. To begin this answer, you should use your best thing is here given is that carbon dioxide 150 centimeter cube. So you can see that if you get this, how many moles of carbon dioxide is present? If you get 24,000 centimeter cube at room temperature, it is 1 mole of carbon dioxide. If you get 1 centimeter cube, 1 divided by 24,000 moles of carbon dioxide, but is generated 150 centimeter cube. 1 divided by 24,000 times 150, you get the answer. It's a carbon dioxide is 6.25 times 10 to the power minus 3 moles of carbon dioxide has been generated. So this is the amount of the carbon dioxide produced. Once you get this answer, you can write down it next to it is 150 centimeter cube means this much of moles of carbon dioxide. Now you can turn closer to the balanced equation. So the ratio for XSO4 to carbon dioxide is 1:2 to 1. 2 of this gives you 1 carbon dioxide. 1 time is 6.25 times minus 3 mole. Obviously, it is being used up twice of XSO4 to give this much of quantity, which is 6.25 times minus 3 multiplied by 2. 12.50 times minus 3, which comes as 0.0125 mole. So that the X has been reacted in this masses. This exactly comes 0.0125 moles of XSO4 has been reacted. Once you get the molar ratio, it is the last part. Calculate the formula mass you are asking. To get the formula mass, it should be easier. Now you can proceed, because if you get formula means the mass 1.995 grams of XSO4 contain 0.0125 mole. Therefore, 1 mole contain 1.995 grams divided by 0.025 mole. So you get the molar mass of this compound as 159.6 grams per mole. Once you simplify with this, 159.6 comes, so it should be, basically you can refer to 160 also, you can round it off. The very last, the second point of the question would be, having known that the molar mass is 159.6, you are asked to deduce. Deduce what is the identity of X. So you can say 1X plus 1 sulfur plus 4 oxygen. Once you get all these things, it is the mass has been given to you as the molar mass of 159.6. X you don't know, sulfur is 32.1, for oxygen is 64, which comes 159.6. When you add this part, you'll be getting the 0.1, 4 and 2, 6 and 6 and 3, 96 is 159.6. Therefore, X is 159.6 multiplied by 96.1. Which comes the answer 63.5. So X is 63.5, therefore X should be copper, which is the element copper, which has to be the best answer to identify X. And we came to the end of this section B discussion of October 2023, Unit 1 paper. I hope you understood the discussion, as well as it is the basic discussion being done. So hope that you understood, and we'll be meeting up you all again with another paper discussion. If you have any difficulties, you can put in the comment box. So I try my best to answer for your queries as well as your questions. Thank you so much for watching my video. Hope to meet up you soon with another video. Thank you.